Hey, welcome back to IC, or actually we're in IED. Rock and roll, coochie coo, here we go. We're going to do a little review here today over some tolerances. We got that test coming up. The first thing we're going to do is we're going to take a look at, we're going to do a few things here today. We're going to find, we're going to be able to write the inequality. We're going to be able to find the tolerance. We're going to be able to find the lower limit, the upper limit. What are we else are we writing here today? Inequality, tolerance, upper limit, lower limit. And to find out if there is not tolerance, shoot, what is it called? Interference, allowance, there we go. Slash interference. I'm probably misspelling that there for you rock stars, but at any rate, let's start off here with the lower limit. I know it's a little bit out of whack, but there's a couple easy ways we're going to look at this. First of all, I'm going to look at over here at number C. This tolerance here, all right, is giving us both it's the limit tolerance, which in the case here, they're giving us the upper and the lower limits, and that's why we call it a limit tolerance, because they're already giving us the upper limit and the lower limit. So when we have that, our lower limit for this one would be the smaller of those two. So here is our lower limit. When it comes to the upper limit, we got to find out, well, how big can the part be? And that tells us that it's going to be this big, 0.755. Now, there's a couple things that become real easy to do. I would always start with that lower limit and upper limit when we start doing these problems. To do the rest of it now, the tolerance is just the upper limit. I'm going to type it out here for you. Tolerance is equal to the upper limit minus the lower limit. So that in this case, the tolerance is equal to 0.755 minus 0.750. And that tells us then that the tolerance is 0.005, and whatever the units would be on this. So it could be inches, millimeters, they don't really tell us over here on the left. So again, I've been working with this C over here off of the adjustable rocker arm. So we've got the lower limit, the upper limit, the tolerance. All right, so let's kind of separate these, make it a little easier for you guys to see these. Once I have the lower limit and the upper limit, the inequality is real easy. So I'm going to start off with the lower limit. Let me go ahead and write that inequality over here. The lower limit is going to be less than or equal to x, which is less than or equal to the upper limit. Now, let's add the equals to there. There we go. So when it comes to making this inequality every time, I'm just going to follow that format. So I'm just going to go ahead and copy that part right there. Paste it in, so I don't have to type it all over again. You guys are okay with that, aren't you? Well, I guess we'll call it a consensus of me, which it goes 1, 0, motion carried, we'll keep going on. Now, I'm also going to then use the upper limit. So there's our inequality. I took the lower limit is less than or equal to x, and what this tells us is this is the range, all right? This is how small it could be. X, whatever this part, this hole over here, is going to have a range of, it's going to be maybe as small as 7.5, and it could be as big as 0.755. Anything in between is acceptable. So this basically tells us our acceptable range. So we've done the inequality, we've got the tolerance, the lower limit, the upper limit. Let's go ahead and figure out this allowance interference then. Well, our equation for this is equal to the maximum material content essentially for the upper limit minus the MMC, sorry, and this right here is the interior is what I really want to do, sorry, not the upper limit, the interior, and this right here is for the exterior. Well, start off with here then, my allowance slash interference is equal to the interior hole. Well, when is this part going to have the most material content? That's what that MMC stands for, maximum material content. And that's when this hole is going to be the smallest. So we're going to use the 0.750. 0.750. And let's say then that, oh, somewhere down here we got a rod, don't we? Well, heck, we're going to make one up then. We don't have anything over here. So let's just put over here, we got this mythological part. That means I'm making it up right now, people. That's where it's coming from. This rod has a plus or minus, control underline, oh, we wanted a plus, control underline, let's make sure we don't have the underline going here, and it's going to be 0.751 plus or minus point, we got to add a little here, 0 point, there we go. Ignore once, there we go, 0.002. What the heck, we're just making it up. So in this case then, minus the maximum material content of the exterior. Well, this rod, all right, this rod is where we would be measuring the outside. And I'm just going to put a picture on here of a shape. Here we go, we got a circle. So here's this rod. There's the tip of the rod. So when is this rod going to have the most material? That's when it's its widest. So I'm going to go ahead and add the 0.002 to this. That's its, I'm measuring on the outside of this. So again, I'm going to add this. And in this case, I'm going to take 751 plus 0.002, and that gives me 0.753. That is my exterior one. That's what I'd measure from outside. When this part is its biggest, and when is its biggest? Again, when we've added the 0.002. All right, when we've given it, we're at its upper limit. All right, so we use the lower limit for this one, and we use the upper limit for the exterior. Well, at any rate, we get 0.003, and that is a negative number. So what does a negative number infer to us? We have interference. All right, so we've done a little review here again today. How to write the inequality, how to find the tolerance, the lower limit, the upper limit, and our allowance and interference.